Welcome to the Tomorrow Cities Decision Support Environment TCDSE course. In this video, we will discuss what Module 3 under the TCDSE covers in terms of learning how we assess multi-hazard physical and social impact. Before we go into the module, let us talk about the Tomorrow Cities Decision Support Environment. It is a flexible framework to support inclusive and evidence-based decision for urban development, leading to a low disaster risk and more equitable future. In the first step, future visioning, the community forecasts the potential future of the city by discussing and developing plans for urban development. Then, technical experts detail these visions in the second phase into refined visioning scenarios that have a stronger quantitative and spatial foundation. These visions detail the construction of houses, anticipated population, essential infrastructures, and industrial areas, incorporating community aspirations. In the third step of impact assessment, experts and scientists calculate the impact of natural hazards, also incorporating the effects of climate change. Using a sophisticated computer-based approach, they determine the potential human, physical, social, and economic damage these hazards may cause. This module is based on this very stage of tomorrow's cities. In the fourth phase, the impact results presented in familiar metrics are shared with stakeholders for discussions on mitigation policies, implementation challenges, and adjustments to the urban plan to minimize disaster risk. In tomorrow's cities, these components were integrated using a dedicated computational platform developed as part of the project, which we will be learning about in this module and is showcased at the end of this video. This module has been prepared under the leadership of NSET Capacity Strengthening Team with the support from the national and international team of tomorrow's cities. The course is targeted primarily to a technical audience working in all sectors like the government, academia, private sector, and the non-governmental sector. Let's now discuss the specific objectives of the module. First of all, it aims to familiarize participants with hazards and their modeling aspects, including earthquakes, floods, landslides, debris flows, and fires. Then it acquaints participants with single and multi-hazard vulnerability and the selection of functions that define them. Following that, the module covers the consequent social impacts that affect people's lives and introduces participants to the metrics used to measure these impacts. Finally, it aims to familiarize participants with the computational platform developed through Tomorrow's Cities. Module 3 is a 16-hour course that contains 13 technical sessions, combining lectures with exercises to ease the participants in understanding these diverse topics. Some sessions also include a walkthrough of the modeling software used. The sessions can be in person or online, spread out ideally across 3 to 5 days, depending upon the need and convenience of the participants. We will now dive into what we learn in each of these sessions, which are broadly categorized into multi-hazard modeling, physical infrastructure impact, social impact, and computed impact metrics. Starting with the seismic hazard session, here we develop an understanding of various terms used in seismic hazard analysis, learn about scenario and physics-based approach, and familiarize ourselves in performing basic tasks in seismic hazard and risk analysis using the OpenQuake platform. In the flood sessions, participants will interpret the inputs, outputs, and processes related to flood hazard modeling and use its output for designing interventions. They also learn about the applicability of tools, models on flood hazard modeling in different contexts such as Caesar list flood. Along with floods, participants will learn about the properties of debris flow and how they initiate. They will also learn to qualitatively summarize how debris flow properties and source conditions are encoded into mathematical models for their dynamics and hazards. The session also includes a modeling exercise using the LaharFlow web tool. In the landslide session, participants will learn about landslide types and causes, hazard assessment scales, and local capacity diagnosis. They also learn about local landslide issues, interpret city-level results, and their relevance in decision-making. The session contains a hands-on overview of a GIS-based tool as well. Next, learning about fire hazards, participants will understand the dynamics, fire modeling prerequisites and outputs, and fire hazards in urban planning. They will discuss the safety provisions in building codes and policies. Now, many of the hazard modelings discussed are incomplete without considering the effects of climate change. Therefore, in a focused session, participants will gain an overview of climate change impact assessment and interpretation of future climate data, including extreme precipitation indices. They will understand methods of general circulation models called GCM, GCM selection, bias correction, and statistical downscaling. They will also learn about spatial and temporal variation of past extreme events and their importance for flood analysis, as well as projected changes in future precipitation. Finally, through this session, participants will understand the linkage of climate change analysis to TCDSE and rainfall extremes implications for urban flood risk, along with practical tasks like downloading the processing GCM data. After learning about how hazards impact the natural world, we move towards the impacts that they have on physical infrastructure. In the single hazard vulnerability session, participants will learn about fragility and vulnerability, recognize probability and uncertainty in fragility, and categorize these fragility curves. They will also identify parameters for formulating fragility curves and understand vulnerability analysis for buildings in earthquake and flood scenarios. Following this, in the multi-hazard vulnerability session, participants will understand the significance of multi-hazard analysis, recognizing that it is more than just the sum of single hazard assessments. They will discern between level 1 and level 2 hazard interactions, identify necessary inputs for multi-hazard analysis, and assess the impacts of various hazard scenarios. We need to apply many impact models in our risk assessments, all of which cannot be formulated for each study case. In a dedicated model selection session, participants will learn to apply a bespoke method developed through the Tomorrow Cities project for scoring, selecting, and ranking these physical impact models for multi-hazard risk assessment. In the session on network analysis, participants learn to employ graph theory for infrastructure modeling, distinguish between connectivity-based and flow-based analyses, and learn to conduct infrastructure performance assessments before and after hazard events. The session engages the audience with exercises on the go. Now, entering the social impact session, participants will be familiarized with the concept of social vulnerability in disaster risk reduction and discuss the TCDSE's method for evaluating social impact. From this point on, the focus shifts from impacts to hazards on infrastructure to impacts on people's lives. Following this topic, we have the characterizing impact metrics session, where you identify pertinent impacts of natural hazards and describe the key metrics used to measure them. Computed impact metrics offer formal summaries of these social impacts that help risk characterization in a quantitative manner. For example, how many people get displaced or how many students lose access to education. The session includes methods for identifying natural hazards, outlining required data sources and concepts in merging physical and social impacts for characterization. This was a summary of the sessions that equips the participants of Module 3 with a sound set of knowledge and skills related to hazard modeling, together with physical and social impact assessment. As mentioned earlier, the module contains a comprehensive session on the computational platform, developed as part of Tomorrow Cities. It is a powerful tool for assessing social and physical impacts of multi-hazard scenarios. In the session, the participants will learn how it allows users to simulate various hazards such as earthquakes, floods, and debris flows within the study region. Users can input exposure data, including information on urban features like land use, buildings, households, all the way down to the individuals. We will also see the capability of the tool to load vulnerability data, such as fragility and vulnerability models, to assess the susceptibility of infrastructure and populations to different hazards. Participants will also learn how hazard data, representing different hazard scenarios, complete the input required for the simulation. In the platform, once the necessary data is loaded, participants will learn how users can proceed to formulate policies and calculate impact metrics to assess the potential consequences of multi-hazard scenarios. We also go over how the results of the impact metrics can also be viewed in disaggregation and on maps for better visual understanding. In summary, the overview of the computational platform will provide an idea on how it allows stakeholders to observe the impacts of disasters in the changing scenarios, serving as an important tool for making risk-informed decisions. This was all about what we learned in Module 3. With sessions on hazards, physical and social impact assessments, and a dedicated session on the computational tool, the participants will be able to apply the knowledge and skills to derive the impacts that various natural hazards may have on the infrastructure and in the lives of the people living in future cities. Thank you very much.